Welcome back to FastTrackAI, where we keep you on the cutting edge of artificial intelligence. Today, we're unpacking 3 recent research papers that each offer crucial progress on one of AI's most stubborn limitations, hallucination. But they do more than that. Each of these works illuminates a path toward AGI itself. By reducing hallucinations through structural, social, and sensory coherence, these papers move beyond surface improvements and into the territory of foundational intelligence. Let's break down how each paper works, what was tested, what was learned, and why these ideas matter more than they might first appear. Let's start by reviewing the papers. Paper 1. Multi-agent systems and cross-model communication. This paper introduces a heterogeneous multi-agent system where each agent is a fine-tuned LLM or vision language model trained on a specific domain: programming, factual reasoning, mathematics, or vision tasks. Rather than using one giant model for everything, the system mimics expert collaboration. The setup, a controller model, orchestrator, decomposes tasks and assigns subtasks to domain experts. Agents solve tasks independently, then return outputs to the orchestrator. Conflicts in agent answers are resolved by prompting another model to adjudicate. Why it works. Cross-agent disagreement detection allows internal self-correction without external supervision. Each model acts like a peer reviewer for the others. This reflects the way human cognition and social reasoning work. We aren't single minds, we are feedback loops within communities. The benefits are clear: improved factual accuracy, fewer hallucinations, and a structure that mirrors what may be necessary for distributed general intelligence. Paper 2. Explicit knowledge, graphs and causal inference. This work focuses on structuring model outputs into causal graphs, not plain text. Nodes represent entities or events. Edges define cause-effect links. The model must explicitly declare the relationships it assumes. Why this matters? It forces transparency. Instead of hiding reasoning in a soup of prose, causal chains are drawn explicitly. It enables direct validation. Graph-based reasoning is easier to check, update, and debug. Notable gains: significant performance improvements on causal benchmarks like COPA and causal QA. Clear increases in abductive reasoning, the ability to infer the best explanation from partial data. Abductive reasoning is key. It's what lets a mind propose world models that explain observed events, then revise them when new evidence arrives. This is how science works, how detectives solve crimes, and how we learn. If AGI requires any one meta-capability, it's this. And the use of explicit graphs provides not just a better answer, but a way to audit and improve how that answer was derived. Paper 3. Embodied understanding through world models. This paper is about grounding AI in physical simulation. Instead of making guesses based on text patterns, the model interacts with a virtual environment through visual perception and a physics engine. Here's what they did. They used 3D scene renderings to answer spatial queries. Can object A fit under B? And linked LLMs to a physics simulator that plays out interactions before generating responses. Outcome: near-zero hallucinations on physical reasoning tasks. Accurate inferences not based on probability of language, but possibility within a modeled world. Broader implication: this setup could become a reality-based testbed where multiple models propose abductive world models and have them evaluated against grounded simulation. It mimics real-world falsifiability. If your model says an object can pass through a wall and the simulation proves it can't, your theory fails. That kind of feedback is rare in language-only systems, but it's vital to truth-seeking systems. It's how hallucinations can be not just reduced, but disproven. And now, connecting the dots. Let's talk hallucination. AI hallucinations, confidently false claims, are often treated like bugs. but they're more like symptoms of ungrounded reasoning. Humans hallucinate too. We believe false things. But society acts as a buffer. We have others to reality check us. When a person hallucinates, their social network often intervenes. The Burari deaths in India, 11 family members acting on a shared delusion, show how dangerous hallucination becomes when isolated. AI is currently a solo mind, no network, no peers, no counterbalance. These 3 papers suggest an antidote. Paper 1, Social Correction via Multi-Agent Disagreement. Paper 2, Internal Reasoning Made Explicit, so it can be tested and corrected. Paper 3, World Model Verification, Ideas Tested Against Simulation. Each paper targets a different hallucination vector, social, structural, and sensory. And together, they point to something more ambitious, an AGI system that is not a single monolith, but a cooperative network of reasoning agents. Key insight: if hallucination is epistemic drift, then only feedback loops can correct it. That's true in humans, and increasingly in AI. This leads us to the real point: abductive consistency. Can a system explain its own conclusions in a way that survives competition with alternative hypotheses and survives exposure to grounded environments? That's not a trick. That's how science works. That's how sanity works. And that might be how AGI needs to work. Implications for AGI. Maybe it isn't just about larger models. It's about systems that reflect on their own thinking, collaborate with peers, test predictions against real or simulated environments. These papers show that collaboration helps eliminate blind spots. Explicit reasoning structures prevent opaque failure modes. Grounded simulation distinguishes possible from probable. Together, they hint at an AGI design that isn't a brain. It's an ecosystem of minds, each fallible but collectively resilient. This structure can catch and correct hallucinations because it must. Survival in a shared, testable world demands it. And if you want a real red flag for misalignment, think of a GDP maximizer AI. It doesn't care about hallucination unless it affects its score. That's the kind of single goal, single mind AI we should be afraid of. But the kind we're seeing in this research, modular, accountable, testable, might actually want to get things right. Not because it was told to, but because getting things right is the only way to survive in a world where every claim meets resistance. FastTrackAI prediction. AGI won't just be about cognition, it'll be about coherence across agents, modalities, models, and reality. We predict the future of AGI isn't just bigger models, it's abductively grounded, multi-agent, world-anchored minds that verify each other to survive hallucination. You heard it here first. Thanks for watching FastTrackAI. Like, subscribe, and we'll see you in the next one.